guys, today our lesson is on solving equations, and these equations are going to have either no solution or an infinite number of solutions. So these are also called special cases when this happens. So if there's no solution to an equation, or if there's an infinite number of solutions, that's a special case. It's kind of an odd thing that happens occasionally when you're solving for x. So to give you an idea of how this could possibly occur, think of a problem like this. So we have an equation x plus 2 equals x plus 5. If you think about this logically, we're not going to solve it. I have some number x, and it has to be the same thing. So you have the same number on the left as you do on the right. And on the right side, I add 2 to that number. And then on the left side, I add 5 to the number. So what number could I possibly come up with for x so that when I add 2, it's the same as when I add 5? It'll never happen. No matter what number I choose, adding 2 to a number will be different than adding 5 to that same number. So this is an example where the answer is no solution. And when you're working it, it's not always as obvious as this. Some of these equations get lengthy, and so you can't tell just by looking at it. When you're solving the equation, what happens for these special cases is I'll start by subtracting x from both sides. So they cancel out here, and they also cancel out here. And what I'm left with on the left is 2 and 5 on the right. And what I get is an equation. It's got an equal sign. You still have to write this part. There's no more x's. They've canceled out on both sides. So that's how you know it's a special case. And I get this strange thing that says 2 equals 5. And since 2 does not equal 5, it's not a true statement, it's not a true equation, our answer is no solution. Okay, another way of writing no solution is, it looks like a 0 with a line through it. That's like an abbreviation for no solution. Okay, similarly, we have all numbers as a possible solution where it could be anything. That's what an infinite number of solutions means. It means that x could be anything. And an example of that would be this. So here I have x plus 3 equals 3 plus x. Well, taking a number and adding 3 to it is the exact same thing as taking 3 and adding that number to it. It's just the order doesn't matter for addition. That's the commutative property at work. So it doesn't matter what number I pick for x. If I add 3 to it here or here, these two are going to be equal no matter what. So if x is 5, for example, then 5 plus 3 is 8, 3 plus 5 is also 8. It'll always work. If x is 2, then I get 2 plus 3 is 5, 2 plus 3 is 5. It always comes out to a true statement, no matter what I use for x. We call this an infinite number of solutions. So there's a few ways to write that. Sometimes we say an infinite number of solutions. Sometimes we say what's called all real numbers. Now the abbreviation for all real numbers looks like an R with an extra line. We also call this the identity. So every now and then you'll see it called the identity, and that just means x could be anything. Now when you go to solve it like a normal equation, just like before, these are going to be a lot longer equations. You won't be able to tell just by looking at it if your answer is all reals. We start solving it like normal. We subtract x from both sides. Again, like with the no solution, they cancel on both sides, so there's no more x's on the left or the right. But what I do have left is 3 here and 3 here. The difference here between the other one is now I have a true statement, because 3 does equal 3. So since that is true, that's how I know my answer is any number or all real numbers. Okay, so let's practice with a couple of different problems. So these are longer ones. You're not going to be able to tell just by looking at them. You have to actually go through the process to solve. So I'm going to start solving this, and we start solving this by distributing first. Remember, you're distributing a negative, so that will become plus 2v, and then I still have a minus 2. After we distribute, I'm going to combine these two like terms, the negative 2 minus 2, and rewrite everything else, so that's minus 4, or negative 4. Okay, and now I'm going to get rid of the two v's. I'm going to subtract 2v from both sides. They cancel on both sides. You have to write something, and when there's nothing else left on that side, it's 0. You have to put something. 2v minus 2v is 0. These cancel, but I still have a negative 4 here. So is 0 equal to negative 4? Is it true or not? This one is not true, and there's no more x's left, so that means my answer is no solution. Or we can use that abbreviation. Sometimes they also call this the empty set. It means that there are no answers for x. X is empty. There's no possible values for x to be. All those mean the same thing. There's no solution. It doesn't matter what you put in for x, or v, I should say. The answers, they won't work. Okay, let's do one more equation. One more after this, actually, 2 more. So I'm going to distribute first to start solving this. So a negative 6 times a negative 7 is a positive 42x. And then a positive 30, negative 6 times negative 5. I'm going to subtract 6x from both sides. So I still have a 30 over here. Over here I have 36x plus 30. And I keep on working like normal, subtract 30 from both sides. This cancels out on both sides, but it becomes 0. You have to put something there. I still have 36x here. Notice I still have x. X has not canceled out completely. That means this is not a special case. It's neither no solution nor all real numbers. This is an actual answer. I have to keep solving. So this is a case where x equals 0. It's not no solution. It does have a solution. The answer is 0 for this case. So if you still have x's left, like we did right here, then you do have a solution, so you have to keep solving like you normally solve. So this was not a special case. Let's try one more. So I'm going to start off again by distributing that negative 2. So negative 2 times negative 2 is positive 4. Negative 2 times negative 5 is positive 10n. And I'll rewrite the rest. And then let's combine like terms. 10n minus 3n is 7n. And then we keep on solving. I'm going to move the ends. You might recognize right at this stage that we have the same thing on both sides of the equal sign. When that happens, that means the left side is going to be equal to the right side no matter what I do, because they're the exact same thing. So my answer for what n can be is all reals. And you might recognize it right here at this step. If you don't, you keep on solving by subtracting 7n like I'm doing right now. I'll have a 4 on the left side and a 4 on the right side. At this point, we look to see, is this true? Yes, 4 does equal 4. That's how you know it's a special case, because we don't have x or n left, so it's either no solution or all numbers. And since this is true, that makes it all real numbers, or an infinite number of solutions. So that's how you can tell if your equation is going to be either no solution or all real numbers. Basically, your variable cancels out on both sides. And if what you're left with is a true statement like this, it's all reals. If it's a false statement like 3 equals 5 or 0 equals 2, then it's no solution.